Yeah, it stopped recording and it just died, and so I think I lost that. But here's the results still here, so here we go. If we're given pH and they ask for one of the other things, there's more than one way to get there, and sometimes one way is easier than other ways. Personally, I like to avoid this. Whoops. Personally, I would prefer to avoid this transition if I have to, if I can, because this one's so much easier. So if I'm given hydroxide ion concentration and I need pH, it's easier to find the pOH and then subtract it from 14 to get the pH. Instead of taking the hydroxide ion concentration, doing this and converting it to hydrogen ion concentration, and then taking the negative log. So you can choose which way you go around the circle. You can go either way. So let's look at this. I don't know why I did that. Where are we going here? Okay, calculate the pOH for each of the following solutions. So this first one, they give us that hydrogen ion concentration. Well, what if we calculate the pH of that? The pH of that equals the negative log of 1 times 10 to the minus 4. 1.0 times 10 to the minus 4. And because it's 1.0, we can do that one in our heads, and that ends up being 4.00. But feel free to use your calculator. And then if I want to know pOH, pOH plus pH equals 14. So pOH equals 14 minus is 4.00, so it's 10. That's the pOH. Isn't that nice? See, Cody's loving this because he heard it before, and it probably didn't make quite this much sense the first time. It makes so much more sense the second time you take a chemistry class. Yeah, and knowing your math really, really helps. Really helps. So any questions about that one? There's another way to do it. We're given hydrogen ion concentration. We learned how to calculate the hydroxide ion concentration. And then we can take the negative pH of that. I think that one's more work. Then part B is going to be easier. pOH is the negative log of the hydroxide ion concentration, 0.040. We don't need to put the M in there. 0.04 log 1.40. That's the pOH. The calculator is saying 1.39794. I want to keep 2 decimal places, so 397 rounds up to 40. Any questions? Yes. The pOH and the pH are calculated in exactly the same manner. It's just that you're using the concentration of hydroxide for the pOH and the concentration of hydrogen for the pH. So the pH of a solution is 5.85. What's the hydroxide ion concentration? Well, I think it's easiest to find the pOH first. That would be 14 minus 5.85. Which is 8.15. And then the hydroxide ion concentration will equal 10 raised to that value as a negative. And that should have two significant figures, so it's 7.1 times 10 to the minus 9 only. We're out of time, and hopefully we're out of slides. Nah, that's okay. We're kind of out of slides.
Can we go back to that?
Yeah.
Yeah.